Okay, so I wasn't taping that. So again, here's our list of basics. We're going to add product rule and quotient rule. So how do we know it's a product rule? 2x, not a product rule because 2 is a constant. That makes it a basic. Y equals 3e to the x. E to the x we know. 3 is a constant. That makes this a basic. Y equals x times e to the x. Now I have one function times another function. That throws it out of the basic category. No longer basic anymore. So the product rule is this. If I have some function that's a product of two functions, and I used capital F and capital S on purpose, this stands for first. And so you guess that stands for second, yes. Because when you do this rule, you're going to say these words in your head. I still do, and I've been doing this a really long time. You're going to say, first times derivative of the second, plus the second times the derivative of the first. And you're going to say that in your head while you're writing it down. So let me just give you the rule then. So the rule is this. It has two pieces, both the quotient rule and the product rule, and next time the chain rule all have two pieces to them. Make sure you get them both. So here, this one will be, the first term will be whatever this first function is, times the derivative of the second one. So there's your first term. And then we're going to add to that, if you had to guess, what do you think? Yeah. We usually say it this way, the second times the derivative of the first. But you can certainly reverse those orders. So if you look at what we've done, we've handled, each term has a first and a second in it, and each term, one of them has a derivative and one does not. So most people, like I said, will say in their heads, first times the derivative of the second, plus the second times the derivative of the first.
Can we have to divide it by 2 or something?
Nope. Yes.
Is the last one, is that the F prime? Okay.
Yeah, it's an F, sorry.
Wouldn't it be like obtusely large though? Because you're...
Let's do some examples. And then we'll see. So I'm just going to write this over here. So if we have first times second, that's what our function is. Then the derivative will be first times the derivative of the second plus the second times the derivative of the first. Okay, so let's do some examples. Sometimes we have to use this. Sometimes it's easier to use this. Sometimes it's a choice whether we use this or not. We'll look at some different examples for that. All right, so here's one. F of x equals 3x cubed minus 2x plus 1 times 4x squared minus 5. What kind of a function is this? What happens if I multiply it all out? What do I get? Well, it's not a quadratic, but it is a polynomial, right? If I multiply this out, I'm going to get an x to the 5th term and an x to the 3rd term and x to the. It's just going to be a long polynomial. Do you want to multiply this out? I don't want to multiply that out. I mean, you could, but instead, if we want to define the derivative, we can recognize this: first and second. Does everyone agree that those are two functions multiplied together? So if I have a first function times a second function, then I can do the derivative this way. So the first function, that means you literally write it down, copy it down. And what is then here? And if it helps you, go ahead and label these first and second, whatever you need to do to keep everything straight. The thing with product, and even more with quotient, is that there are going to be a lot of pieces to keep track of, so think of a system that will work for you. What would be the derivative of the second?
8x.
Yeah, 8x. So that is this term. I've done one of the terms. Now I need to do the second term. The second term says just write down the second function, so 4x squared minus 5 times the derivative of the first. So what's the derivative of the first?
x squared.
Minus 2.
X squared minus 2. Can we leave it this way?
Wonder we have to add it.
Yeah, you really should probably multiply this out and add everything in collective like terms. Can I leave you guys to do that at home, or do we want to spend time doing that in class? I think do that at home. Yes?
So, I mean, does this mean that this rule essentially works in backwards order as well? If we have like an overly complex polynomial and we see a way to factor it and that turns out into multiple functions, we can use this
Yes.
rule?
We're going to get to that today.
Okay.
Yeah. Yes. Yes. Not very often, I will say, not very often, but yes. Okay, so let's look at another one. Find dy dx. And again, I'm trying to give you different forms of the derivative just to remind you what, so this says find the derivative, dy dx also says find the derivative for y equals 3x cubed times 2x squared minus 1. Is this a basic? Is it one function times a number or some? No, I've got a function here times a function here. So this is definitely not a basic. Could I make it a basic? Yeah, I could just multiply that out. And so we're actually going to do it both ways and see. So if I treat it as a product rule, first, why don't you guys do this one? You guys do this one and I'll do this one and we'll see how we do. So remember, you've got first and second. So go ahead and apply the rule. First times derivative of the second plus second times derivative of the first. And really, I promise you, if you say those words in your head, it will go better for you. I know it sounds silly. Go ahead and when you get your final answer, multiply it, simplify it, collect like terms. Get it right. All right, so let's start taking a look. Again, the pattern. First times derivative of the second plus second times derivative of the first. So first times derivative of the second. Derivative of the second would be 4x. Plus the second, write down the whole thing, times derivative of the first. Start multiplying out, so we'll get 12x to the fourth, 18x to the fourth minus 9x squared. Combine them. Did everybody get this? Did I do it right? It's early for me too. That's the other thing I meant to ask. If you guys had a preference, how many people, if you had a choice between an 8 o'clock class at this, or an 8 o'clock class, or a 9:30 class, how many prefer 8? And how many prefer, all right, so yeah, really, this is kind of like a vote. Yeah, so, right, if you prefer 8, raise, so keep them up so I can count. 1, 2, 3, 4, 5, 6, 7, 8. Did I get that right? 8, yes, and how many prefer 9:30? Everybody else? Okay, because, and for the 8 o'clock people, is it because of work constraints or other classes? No? Okay. I'm just trying to get a sense, because I know 8 o'clock is kind of early for some people, but for other people it's a necessity. So, okay, so what's the other way to do this? The other way is to multiply this out in the first place. And in this case, that might be easier to do, because it's an easy multiplication, right? So what would I get? I get 6x to the fifth minus 3x cubed. What's the derivative of this? 30x to the fourth minus 9x squared. Same answer. So as is true in math, oftentimes there are multiple right ways to get to the one right answer. In this case, probably multiplying out would be easier. In this case, I think probably not. All right, so let's look at another one. Here's one where you really have to. You don't have a choice. Okay, so let's look at this one. Find d dx of 3x cubed e to the x. So remember, d dx is an instruction. It says take the derivative of. So as soon as you take the derivative, you've done the instruction, so you don't write it anymore. The same with limits. When you say the limit of, and then you plug in, now you have done the limit, so you take the limit wording off. Okay, so is this a basic? That's our first question always. Is it a basic function? No, because there's no way that's a basic function. If it were 3e to the x, that would be basic, because I'm just multiplying by a number. This is not. So let's look at the derivative first. Do you guys want to do this one too? Why don't you guys do this one also? And then we'll talk about how we typically simplify this. You don't have to, but when it goes to solving equations, I'll give you kind of the standard form to write it. So we're going to start with first, 3x cubed times derivative of the second. Derivative of e to the x is? E to the x. Love that. Plus the second times the derivative of the first, which would be 9x squared. Okay, so standard way to write functions where you have a polynomial and an exponential is that the polynomial part goes first and the exponential part goes second. And if you have an exponential in both, you factor it out. So altogether then I get 3x cubed plus 9x squared times e to the x. That would be how you'd write it. So the e to the x part always goes last and the polynomial part always goes first. And if there's any common exponential, go ahead and factor that out. And we're going to come back to this one. Is that okay? All right.
Wouldn't it be 2ex?
No, that's a good question. So e to the x is, how do I describe this? It's like you're factoring out. If I factor in e to the x out of this one, I have this is what's left. And if I factor in e to the x out of this one, that's what's left. So it'd be kind of like when you factor out, if you had like 3x squared plus 3x, if you factored the 3x out of the first one, you have left x. And this is an important thing because some of you missed this part, I think, on a test or a homework. If I factor 3 to the x out of this, what do I have left? 1, not 0. Okay, so it's the same thing I'm doing here. I'm just factoring that e to the x, and then these are the parts that are left.
Okay.
All right, so let's look at this next one. This is example 4. So find y prime 4, y equals x minus 5 times cube root of x squared plus 2. So the very first question is it a basic? No, right? And not just because we see cube roots and things, but because we have one function times another function. That's what puts it in the product rule. We have a whole function times another whole function. Are we ready to do the derivative with it as it stands? No. I mean, this one's good, but this. How do I rewrite cube root of x squared? X times the 2/3. So the square stays on the x, and then the cube root becomes the bottom of the fraction of the exponent. Becomes the cube, the 1/3 part. Okay, so now we're ready. So first times derivative of the second. What is the derivative of the second? That'll be 2/3 x to the minus 1/3. So far, so good? Plus the second, x to the 2/3 plus 2. What's the derivative of the first? 1. Nice. Okay, so let's clean this up. Yes, we need to multiply this out. This is x to the 1, so remember we're just adding exponents, so I'm going to have a 2/3 x to the 1 times x to the negative 1/3 would be x to the 2/3 minus, it's like 5/1, so 10/3 x to the minus 1/3 plus x to the 2/3 plus 2. We're going to collect up like terms. I see x to the 2/3. So that would be one of them plus 2/3 of them, so 5/3 x to the 2/3 minus 10/3 x to the minus 1/3 plus 2. And I think we can leave it like that. The other thing that you could do, x to the minus 1/3, you can also write as 1 over x to the 1/3. There is a way to get this all over one denominator. I'm trying to think of what. We'll come back to that. If we have time, we'll come back to that. Because this is going to be a hard one to set equal to 0 the way it stands. So let's just look at that briefly. So if this is, all right, so we'll come back to this if we have time. If I wanted to set this equal to 0, I really need to get it, because this is, so this is really like this, right? Which means I've got a fraction. As soon as you have a denominator somewhere, you need to get one whole fraction equal to 0, or multiply both sides by x to the 1. We'll get back to that. All right, so now let's look at, so now we've done product rule. Now we need to add quotient rule. If you had to guess, what do you think quotient rule is going to pertain to?
Division.
Division, right? So I can divide by a number. That's still a basic. So let's look at some examples of what is quotient rule and what is not. Is that quotient rule? No. Dividing by a number is like multiplying by a number. That is a basic. Multiplying by a number is a basic. What about this one? Is this a basic? No. Now I've got a function divided by a whole other function. This is a quotient rule case. Okay, so quotient rule pertains to, and I'm going to use T and B. See if you can guess why.
Top and bottom.
Top and bottom, I know. Isn't that really easy? Yes. So we're going to write the rule based on top and bottom. And again, this is one that I want you to say in your head, particularly this one, as you're writing out the answer. So here, our rule will be this. The bottom. You always start at the bottom and work up, right? So bottom times the derivative of the top. Minus the flip pairing. The top times the derivative of the bottom. All over, everybody says that, all over the bottom squared. I'll write this one. Yes?
So whereas the addition of the product rule, it doesn't really matter how you do it.
Here it does,
has to be
yes.
bottom times
You have to start with the bottom. So correct. Because the product rule is an addition, you know, you can and it's multiplication, so you can really, as long as each term has one derivative and the other one not,
Right.
that one's fine. This one, yes, you have to do it in exactly this way. So you start with the bottom. The bottom, and so if this one is not derivative, then this one is. Bottom times the derivative of the top, minus top times the derivative of the bottom, all over the bottom squared. Okay, so let's just write that out here. So if we have top divided by bottom, the derivative would be bottom times the derivative of the top minus top times the derivative of the bottom, all over the bottom squared. Okay, so let's do some examples. These ones get long and kind of just because there are lots of functions in a fraction, and so just, you know, understand that the answer will not be one line, and that's okay. All right, so let's look at this one. 2x squared over x squared plus 3. So the derivative. So first, is it a basic? That's always our first question. Is it a basic? No way. We have a whole function divided by another whole function. And is the division easy to do? No, because this is a bigger term than something. This is not a simple term in the denominator. So we're going to start with the bottom, and just write down what the bottom is, times the derivative of the top, 4x, minus the top, times derivative of the bottom, all over the bottom squared. Do not multiply out the bottom, ever, okay? Because the questions you're going to ask about this may ask about vertical asymptotes, it may ask about, you may want to do a sign chart where you're going to use zeros from the top and the bottom. You're never going to want to multiply that out, so just don't bother to take that step. All right, so now let's clean up the top. So 4x times x squared, 4x cubed, plus 12x minus 4x cubed. Is that right? Did I do that right? Yeah. So I get 12x over x squared plus 3 quantity squared. Does that seem too simple for a final answer? Oh, that seems simple to me. The 4x cubes canceled. That seems... It actually is... the next example, I'll show you a little bit about where this comes from. If you were to rewrite this, I could rewrite it. I'm just going to throw this out here. Did I do that right? No. Does everyone agree I haven't changed the problem if I add 6 and subtract 6?
Right.
But now now I'm going to split it up differently. So now I'm going to write it as 2x squared plus 6 over x squared plus 3 minus 6 over x squared plus 3. I wouldn't expect you to do this, but just so you can see where it comes from.
Right.
What does this equal?
Well, I mean, it depends on the value of x.
No.
2x squared over x squared plus
How do I factor the top? Can I pull out a common number?
Yeah.
2 times x squared plus 3. Huh. So this is really 2 minus 6 over x squared plus 3. True? Derivative of this is 0. And so now the derivative of this, it makes sense that it could be something, this something. And we'll come back to this next time when we do chain rule. So yeah, this one turned out really easy. I would not expect you to do it that way. That's not the easy way. I just wanted you to see where it came from. But now let's look at this next one, which there is an easier way to do it. So this one, trying to rewrite it, you have to get creative. Trying to rewrite this one, you have to get creative because this is not a simple denominator, right? That's not a simple denominator. Let's look at this next one.
I feel like I just watched factoring for the first time.
You just watched what?
Like when you were in like middle school, you saw someone factor.
Yeah.
Like, how did you do that? Where did you come
Yes.
up with those fake numbers from?
Yes. Yeah, no, that was just, every once in a while I'll throw something out there, and if you get it, great. If you don't, that's not something you're going to need to do. This one is, though, so let's look at this one. Find dy dx for y equals x cubed plus 7 over x cubed. I'm just going to rewrite up the previous one again. How are these two different? They're both just, quotient. This denominator's really easy, and this one's not. So this one has two different ways you can do it. Let's do it as a quotient rule for practice. So you guys do a quotient rule on this one. So bottom times derivative of the top, do the whole 9 yards. And then we'll look at how else to do that one, which actually you already know the other way.
Wait, I have a question. Couldn't the x cubed on the top and the bottom just cancel out?
Yes, but not, and get 7, no. Yes and yes, I can rewrite this, but we need to be careful about that. Let's do quotient rule first, and then we're going to do that one.
You literally just showed us how to do it, minus and stuff.
Well, no, hang tight. We're gonna come back to that. Quotient rule first. Let's practice the new material. Quotient rule first. So bottom times derivative of the top minus top times derivative of the bottom, all over the bottom squared. You guys give it a go first. And then we'll look at your notes. All right, so let's go through bottom times derivative of the top minus top times derivative of the bottom all over the bottom squared. Now I just start multiplying out. Be very careful about that. That's a minus sign that applies to all the terms following. So when I multiply this out and I get 3x to the fifth, it's negative. And when I get 21x squared, it's negative. X cubed squared, everyone knows is x to the sixth, not x to the fifth, right? You multiply, this is like x cubed times x cubed, so 6 factors. So these cancel, yay. Minus 21x squared over x to the sixth, cancel again. Negative 21 over x to the fourth. That's the quotient rule. Lots of pieces to have to keep track of, so just remember that there are 2 terms in the numerator. Each term has one function with a derivative and one without, but it's very important you start with the bottom. So let's look at how else could we rewrite this. You actually had a problem just like this on test 1. How can you rewrite that? Can you break apart fractions? You can break apart fractions. I could write this as x cubed over x cubed plus 7 over x cubed. That's just like saying that 3 halves is 2 halves plus 1 half. Right? You can just pull those apart. But now, you're right, now those cancel. So this is now 1 plus. I'm going to rewrite this because, is this a basic? Actually, this is a basic, right? I mean, I could treat it like a quotient, but really I could write this as a basic because this is just 7x to the minus 3. And what is the derivative of this? 0 plus negative 21x to the minus 4, negative 21x to the minus 4. Yes?
That's about to be 30 minutes.
Oh, thank you. That's a good place.